With this workflow, you can build a RAG agent that not only is able to store your information, but is able to dynamically delete it so you're not cluttering up your database with information that you got from 2-3 months ago that's no longer relevant. It doesn't confuse client information across accounts. This agent allows you to build RAG like never before. All right, and let's go ahead and see how this guy works in action. So let's come over to Slack, and I'm gonna go ahead and say, hey, I have a document I need uploaded. Please put it into the Supabase. And so come over here, we're gonna attach my file just here in downloads. It's a report that I had just made with my research report writer as I was filming that video from a couple days ago. Let's go ahead and send it to the bot. And what's gonna happen is it's able to have you have information in your message to it, both with text and audio. And because normally all my bots have kind of this initial structure here, well, if I'm going to attach a document, I need to do a slight variation for the audio, but that's neither here nor there. The point of this bot is it's able to both take inputs and answer your questions. So it's a RAG that can do both. And here we got a response back that it has been successfully uploaded to the vector store and is ready for retrieval. Great. Let's go ahead and say, what effect is AI having on the job market? Because that's what that document was about. So then it's going to go ahead and it's going to go through the process down here. It's going to answer my questions. Now, this is not technically a true RAG. It is a RAG, but I have one special node right here that makes this dynamic. This is a database that's going to clear its memory about every 2 weeks or however long you choose to set it. That way, this memory is no longer just going to be stored there forever and ever and ever, taking up your vector store database forever. And maybe you just want to be able to ask a document questions and then not have it stored forever. So that's what this is for. If you remove that one node, it becomes a RAG though. So let's see, we got it. It pulled it from my document. It's job displacement, job creation and transformation, sectoral and regional variability, skill demand, economic and social implications, labor market dynamics. Well, that's all well and good, but let me see here. Let's actually come into the document and see if we can't pull something more specific. That way we can be sure. Here we go. Here we go. For example, software developers are expected to experience 17.9% growth. So software developers, let's ask it, how much growth should software developers expect for jobs? I don't know. That was weird. Let's see. Give it a moment. It's going to go search that database once more, and it'll return an answer. And 17.9% over the decade from 2023 to 2033. Result in the creation of 300 new software developer jobs, driven in part by increasing demand for AI literate technical professionals. So perfect. It's able to pull specific information from my document exactly how I would hope it to. I can have conversations with this document about anything in it. And like I said, I made it dynamic by adding this one extra node, which will delete old information. So you don't have to worry about just stacking in the information and going, oh man, like, do I really want all of that? Do I want my bot to get confused by everything that I'm putting in? Nope, this is kind of a middle ground between chat memory and long-term RAG storage. I built something that allows it to just be for this document and forget it sometime in the future. As always, you can download this N8N workflow for free from my free school community, where we give away over 30 different business-focused workflows, ranging from social media posting bots, executive assistants, lead and email scrapers, and more, with new free workflows coming out every week, along with tutorial videos, how-to guides, and a community of automation-focused business owners, all looking to collaborate and grow their businesses with AI-powered automations. You can also join our advanced community for weekly tech support calls, marketing and business growth discussions, as well as getting to pick my brain on N8N, AI automations, or business in general. So let's go ahead and actually dig into this bot and show you how it works. Now, if you've seen my other videos on all my other bots, This beginning part should look fairly familiar. There is a change though, and it's right there. And it's right there because of how I thought users might actually interact with this. Well, because we're using Slack here, and because you might send a message to the bot, but that could be a voice message as well as a document. I never know. I never know how users are actually doing this. Some people feel they need to tell the bot what to do, even though there's not necessarily any real need for instructions in it. It's just going to upload. Might as well figure out, the way to do that for the user. So I built it so that you can send it to the bot and allow the bot to understand which file was the voice file that you sent it and which file was the document that it needs to process and put into your RAG storage. So let's kind of go through it one by one. We have our Slack trigger. Our Slack trigger, you set up your bot credentials. If you don't have a Slack bot yet, I got a video link in the description below to show you how to do that. Set your trigger event for any event. Channels to watch is our whatever channel you have your bot in. Mine's Patty PA input. And make sure to ignore your bot. Otherwise, you're going to create this recursive loop of the bot responding to itself. It's not so cool. It seems kind of scary because your tokens are burning. We run everything through our code node here. Our code node is checking for what position in our message this message is. Is it the top of the thread? If so, it will create a session ID with our user ID, colon, and then the word top. Oopsie, don't do that. Then the word top. If it's part of the thread, it'll create a session ID with our user ID, colon, and then the thread timestamp. And then that's important because that is how our bot has conversational memory with us. That's how it knows what we've been talking to it about and is able to act on it further. And then it's going to output a bunch of information. It's going to output the session ID, the user ID, any text that you might send it if you send it message via text, the timestamp, the thread timestamp if there is one, identifying whether there is a thread, and any files. It's going to include an array of those files. All of that then gets sent through the switch node. The switch node is a little different from my standard input to my bots. We're still checking if there's an M4A, but we're actually checking if file 0, which would be the first file, or file 1 is an M4A, one of the first two. Now, this is only capable of accepting one document at a time, all right? Please understand that. This is kind of a limitation of the bot. It's only able to take one document at a time, although you can include a voice message if you want. Some people want to talk to their bots. But because I don't know where in the upload process, whether you're going to attach your document first or the voice message first or the voice message, wherever, I have this set to be able to check either of the two files because, again, you're only going to upload one. That's the limitation of this bot. It's going to check for either one to see if it's an M4A, and then it's going to pass that through to do the transcription of your audio message. If you don't send an audio message, it's going to see if you sent any text. If any text, then it passes it all forward. Either way, you have to give it some instruction. You can't just attach a document and send it forward. You have to let it know that this is for purposes of being put into a database. And I did that because this is actually technically a tool that my larger personal executive assistant agent uses. And because of that, you have to give it that instruction. Otherwise, nothing's going to get past the switch node here in order to be able to process through the rest of the agentic flow. Either way, we have two edit fields nodes here. They're the same thing, except one checks file item 0. The other one checks for file item 1. And what it's doing is it's creating a field called audio link with the download link for the audio. That audio, if you send an audio message, then it gets passed to this HTTP node, which is going to download it using your Slack OAuth 2 credentials. You have to use your Slack credentials, not the bot credentials. You're looking for a response format of file, an output of binary. So it'll download the audio file as a binary file that then gets passed to this openai node, resource of audio, operation transcriber recording. Our input is binary, and then it'll output a text output that will then be able to be processed as if it were text. If you send text, we then run it through this edit field node here, where we're just kind of making sure that the name is right. So it's going to label it as a field of text. That way, this edit field node can just call json.text to grab whatever message you sent it. And that is our text here. Creating that field, we're going to create a user ID field, timestamp field, thread timestamp, and a session ID. That's pulling it from the code node. All right, all of that then gets passed forward to this merge node, as well as coming down through this process that's going to check whether there's any conversational history that you've had with the agent so far in this thread. So we come down here, we have an if node that's checking for whether the session ID contains the word top. If it does, it'll bypass our Postgres node because it's not going to find anything if it includes the word top. And I'll explain that in a moment when we get to the end of one of these branches. But if it does not contain the word top, it most likely contains a thread timestamp, which will be kind of how we're logging all of our information for our conversational chat history. And so then it'll come down to this Postgres node. We're using an operation of select. Schema is public. Table is whatever table you have for your bot conversation. I have a limit of 20. You can have it whatever you want, 40, 50, who cares? As long as it fits within the context window of the agent that you're talking to. We're selecting any rows with a session ID, which is the session ID that we set here in this edit field node, which was actually set back here in the code node. And so we're going to find all of the threaded messages that we've had with the agent so far in the thread that we have, pulls it forward. It's going to bring it all into this code node here. That's going to then sort it chronologically. So all of our conversation history with the agent is going to be sorted chronologically so that any future agents has the ability to understand the context of our conversation in order. And it puts all that out, gives us the session ID, as well as the combined conversational history, the previous conversation chain. That's more used for my bigger agentic systems. So if you want to use this as a tool of a bigger assistant, this allows the tool to know what process the last call of the agent has done. That way it knows where it's at. Did you just upload something to the database? Okay, in that case, we're probably still talking to the database. Did you send an email? Well, we're probably not going to talk about the database then, depending on what you're actually telling it to do. But for the purposes of this, it's not necessarily important. It's there just in case you want to add this to a larger agent. And then we have a last added at so that it knows when the last conversation was received at in this one thread. All that information gets put into a merge node, which combines everything from our edit field node before, from our code node. It matches everything up based on our session ID, which will either be that top of the thread message or based on the thread timestamp. One of the two is going to merge it all together and output everything together. Okay, that is the kind of the standard input that I have for all of my bots. But then here's that one node I said is special. This is what makes this not quite a RAG. A RAG, the Retrieval-Augmented Generation, is a database searching AI agent that is able to have all of your information forever and ever, right? And it's always there and you can always go back to it. Well, what if you don't want that information forever? What if, say, a client sends me a document and I want to review it really quick? I want to be able to ask that document questions, but I don't need it to live in my database forever. Well, this Postgres node right here. All right, and if you don't have Postgres set up, I do have a video. I'll have a link in the description below on how to set up Postgres and all the tables and all of that. But what we're doing is we're going to do an operation of execute query, and we're just going to delete from my table name. In this case, I have my table called dynamic knowledge base, where date added, and so we have a column. I'll show you real quick. I have a column called date added, and so wherever it adds it to it, and we'll come down here, we'll see the documents over here. We'll see the new document that I just added. So here's the 14th. That's as I'm recording it. We're going to be looking for that date minus 14 days. All right, or today's date minus 14 days. So it's going to look at it and it's going to look back 14 days, and anything older than that, it's going to delete from the table. And we do that so that we just don't have all this extra information cluttering up our RAG system, so that if I ask this document a question, I'm going to get information from this document and not a document a different client sent me, 2 weeks ago, a week and a half ago. Well, I haven't set to 14. You can set it to 7 days, 2 days, 3 days, whatever you want. Either way, I don't want different clients' information potentially giving me bad information as I'm asking it. So while I'm working, I always have the best information available. And so I put this here at the start of the process, just so anytime I run this dynamic database, it will clear my history. I don't have to worry about old data accidentally getting in there and getting involved and screwing me up. Okay. Now, there are two branches, like I mentioned before. So we have our input branch. I'll zoom out some more. Our input branch is all of this kind of up here. All right. And then we have our response branch, which is this little bit down here. All right. So how does this work? All of the information our workflow gets passes over here to our if node. Our if node is looking for whether it's going to start with file 0. Is file 0 a PDF, an XLS, so an Excel spreadsheet, an XLSX, or an older or newer Excel spreadsheet, a CSV, or a text file? Is it any of those? Is it any of those types of documents? I did not have this set up to be able to accept Word document. Word documents have this whole like extra process you have to go through to be able to get them to work. So I figure instead of a Word document, upload it to your Google Drive and just convert it to a Google Sheet. It'll process, and I'll explain how it'll process Google documents in just a moment. But this can do PDFs, XLS, so Excel spreadsheets, CSVs, and text documents. If it is one of those, it's going to come up here. So if file 0 is one of those documents, it'll come up here. It's going to then create a field called file link with that download link. It then runs it through this if, and if the file link is an M4A, if for some reason our voice message got here, because you never know with computers, they might have happened. If for some reason our voice message ended up here, it gets sent to and does nothing with it. It just dumps it, okay? Otherwise, if the file link is not the M4A, it'll then send it to the switch, which will then run it through a process of extracting the information, which we'll cover in just a minute. Before I get there, if file 0 was not the thing that we wanted downloaded, then let's check file 1. So file 1, if it's a PDF or an Excel spreadsheet or a CSV or a text file, then it'll send it up here. It'll do that file link field name using file 1 as our download URL. And then we do the same if, checking, did our M4A accidentally sneak on through? If so, then it'll just send it to a do nothing. If not, it'll send it to this switch, which switch will then pick which path it needs to do to do the extraction. All right, then one last check. We're going to check whether our text, the message that we sent it, whether that is our voice message or whether that is an actual text, we typed it out into our Slack message to the bot, includes this part of a URL, docs.google.com. So if you've included a Google Drive link of some type, whether it's a Google Doc or a Google Sheet or what have you, it's going to look for it. And if it finds that it sees that docs.google.com URL snippet, it'll then run it through this code node here, which is a regex. And it's going to pull out that Google Docs link for us. And it's going to give us a list of the links. We're in really one file at a time again. All right, it's going to give us that link in a nice clean format that will then be passed to this switch here. All right, now we're talking about the switch. The switch is checking whether our file link, which all of our inputs, so all of these if nodes here, or they're not if, the edit field nodes, this will set file underscore link, this sets file underscore link, and our code node will set file underscore link. All right, so the switch is checking for whether file underscore link is a .pdf, contains .pdf. If so, it'll send it on a PDF track. Does it contain .text? Does it contain .xls, .xlsx, or .csv? Does it contain /spreadsheets/? So if I come over to a spreadsheet real quick, and I come up here, you'll see it has docs.google.com/spreadsheets/. So if I sent it a Google Sheets, link, then that'll show up there and it'll go down the spreadsheet path. If it contains a /document/, that's a Google Doc, up here. And here's my list of videos I'm gonna make. So /document/. And so that'll send it down the Google Docs path. All right. For the non-Google document process, All right, we follow one of these paths. It's either PDF, text, Excel file, a XLSX file, so another Excel, just a different file format, or a CSV file. It's going to be one of those. All right. What we do is an HTTP node. We're going to do a get file URL. We have our Slack credentials here because we are downloading from the document we sent into Slack. So you have to have your Slack credentials to download it. And then we're going to use a response format of file and output as data. So this is PDF. And then it goes into an extract PDF node. So if you're not familiar with that, just come up to here, type in extract. You can have an extract from file. And there's all kinds of different formats that you can extract from. In this case, we're doing an extract from PDF. All right. And then what we're doing is inputting the binary. The binary name was data. And it's going to pull all of the text from the PDF. Now, a word of caution about PDFs. Your PDF actually has to have text in it. It cannot just be an image PDF. If it's an image PDF, this is not the process you would want to use. You would probably want to use some sort of OCR or image model that's able to read the text in order to then output it to then process it. Either way, if you're going to do that, you might as well just run it through ChatGPT real quick and then pull the text, put it into a Google Doc, and it'll run through this process fairly easily. All right, next is a text file. If it's a text file, same thing. We're doing the get using our download link, our Slack credentials, outputting as a binary named data. That'll run through this extract from text file. Our input is named data. Our destination output will be named data as well. All right, and it's just gonna, the name of the field is data. And I think that was named here. No, it didn't name it here. Whatever. It doesn't particularly matter. It's gonna run it through anyway. So double check that does. Yes, it will. All right. If you have an Excel spreadsheet, we're going to have the same HTTP node. It's got your file link, get method, Slack credentials, outputting it as a binary called data. It's then going to run through an extract from Excel extract node. The input is named data. That then is going to aggregate the information. Because it's a spreadsheet, each of the rows of the spreadsheet is, separate data. It's all data that needs to be compiled into one piece of information that can then be put into the database, because you don't want 100, 200, 1,000 different bits of information trying to be uploaded. It's going to overwhelm your system. You're going to crash your table, your Supabase table. So we aggregate all of that together. We then summarize it using the summarize node, using an aggregation method of concatenate, meaning it puts it all together based on the field of data, comma separated, and then it's going to put all of that information kind of into one batch of information that looks right. All right, because the aggregate node is going to have each of the rows separate. We don't necessarily want them separate in the aggregate, even though it is one item. We need to have that put together into one block of text that will be then put into our Supabase table. And so that's what the summarize node does. Same thing with the XLSX, the newer version of Excel file. Get method, file link, Slack credentials, data named binary. We do this download or the extract file, extract from XLSX. The input is named data. Same thing, doing the aggregate based on the data, all fields, summarize it, comma separated again, all the same stuff we just had. All right, that all then gets passed to your Supabase. One more, CSV files. They go through the same process the Excel files do. Here we go. We do a get method. File is json.filelink. Slack credentials. The binary will be called data. That gets passed to this extract node here. It's going to look for the input called data. It's going to extract it. It's going to aggregate that information together, summarize it all together in the same way we just did, concatenating it, and then passing it forward. Okay, that's all of the general files that you can upload. You can always adjust this and add more if you'd like. Word documents, like I said, they're just a pain in the butt to try to figure out, so I didn't include it. Might as well just make it a Google Doc because this can process Google Docs. Let's talk about Google Sheets first. What it'll do is if it's a Google Sheet, because you sent a Google Drive link, then it will run through this process. It's going to download the file through Drive. So resource is file, operation is download, where file is by URL, the file URL link that we've had. And then our output file field is going to be called data. So it's going to download a binary file called data. And it's going to convert Google Files here. And because we're doing Google Sheets, we're going to convert it to a CSV file. And then it just runs through that same process CSV files go through. So extracting from a CSV, aggregating it, summarizing it, and sending it to our database. The docs, the Google Docs, go through the same process. They get downloaded here. Same thing, file, operation download, using the by URL, our file link. The output binary is going to be called data. And our Google Docs is going to be a text file. Now you can do other types of files, but I guess you can make it a PDF, but why make it a PDF when you can make it a text file? And then we just run it through an extract from text file node, same as we had above. The input's called binary or data, the output's going to be called data. All of that then gets passed to our Supabase process here. So technically it's just right here. This is the Supabase process. So what we're doing is we have Supabase. If you do not have Supabase credentials yet, if you don't have a vector store database, I have a link in the description below on how to set up Supabase. What you do is you just connect your credentials here. Operation mode is going to be insert. I picked table name by ID. I just grabbed my table name. And I think I might have had to even put it in. I had to type it in. But either way, you need to make sure that you have a query name match function in your database that matches your table name. And I haven't really seen anybody talk too much about this. I most likely will make a new video on how to do Supabase that includes that information, but you need to make sure that you have a match function that matches your table name so that when you do the search, it will actually find this information. If you don't match the query name, you will not be able to pull the information. All right, so it's going to upload, it's going to chunk the information using, we have an enhanced default loader here. It breaks it all up. It's just going to type as data as JSON, mode is load all input data. We've got our recursive text splitter here, chunk size of 2000, chunk overlap of 200. I split the code with Markdown, and you can use whatever chunking system that you have. I like bigger chunks, and I cannot lie. That was funny. Okay, you can also use the other text splitter. So let's go ahead and just break this, and I'll show you what other text splitters you have. You can do a token splitter if you want, or a character splitter, but I'm going to use the recursive character splitter. I think it just works better. And we have our embeddings model of OpenAI, text embedding 3 small. Don't bother doing another model. Like text embeddings 3 small is cheaper, it's faster, and it works just as good as the large model. And anyway, so it's going to come up with however many different chunks it needs to make in order to be able to process and put everything into your table. That's why we have this limit node here. We're just going to limit to the first item that comes out, because it doesn't really matter to me at all how many chunks there are. It doesn't really matter to me at all. I just need my bot to let me know at this point that it has finished the task. So one item is good enough. So we have an AI agent here that gets my current message. It gets my previous messages, so it understands any context of what we've discussed in the past. And then we run it through this system prompt here. It's just a confirmation agent trained to let me know that it has received the data. It's supposed to say this, just specifically this: your data has been successfully uploaded to the vector store and is now ready for retrieval. You may begin querying at any time. That's it. That's all it's supposed to do. It is not supposed to do anything else. It does not summarize. It doesn't interpret. It doesn't trigger any retrieval. It doesn't speculate about the content of the files or fabricate or anything else. Just let me know that it's done the upload. And even though it says 4 here, don't trust it. It's only set up to be able to do one file at a time. If you have multiple files, upload multiple files over just different messages to the bot. Let it know it's got more stuff to check. All right. And then it goes through this process here. This is my standard kind of ending process for all my branches for my AI agents that will respond back to me via Slack and then upload all of the information that I sent it and it sent to me via Postgres. So we have our Slack node here. We have our bot credentials connected, the bot that's going to be responding to us. Resources message, operation is send. It's going to send to a channel You pick the channel that you want the bot to converse with you in. Message type is a simple text message. Our message is the output of the AI agent that just generated our response saying it was uploaded. And then we make sure that we respond or reply to a message. And the message that we're responding to is the timestamp of our message that we had sent it originally. And this makes sure that it always goes into the correct thread. And so this way it keeps it as a threaded message. It'll generate a thread timestamp, which we will then have here. Make sure, yep, we have our generate a new session ID. This is how we make sure that our information is logged properly in Postgres for our conversational chat. We generate a session ID that has our user ID, colon, and then the thread timestamp. And the thread timestamp would just be somewhere in here in the message that it sends us. We have a field called text, which is the message that the AI agent just sent us. Our previous conversation chain we'll just call dynamic knowledge base. And then time added will be now. And then we upload all that to Postgres. What we do is we have our Postgres account. Operation is insert. Our schema is public. Our table is whatever chat table that you have for your bot. Session ID will be the session ID we just pulled or just generated in our Postgres message, which I guess I could just delete that and just make it JSON because it's the same thing. We're first uploading our human message. Our human message is going to be pulled way back from way over here, this merge node that we had originally combined all our information. That's the text that we sent to the bot. That's going to just send it there. We have all this extra dot replace code here to strip out any offending marks that might accidentally break the upload to Postgres. So any quotation marks or curly braces or square braces or extra quotes of any variety, just strip it all out. Make sure it doesn't break the insert, because we want to make sure that our bot actually has a conversation with us. And then we add a time added as now. And it's just so that everything gets put into chronological order. And then we have one more upload, another operation insert. Schema is public. Table is the chat bot, chat history as well. Same session ID. And this message is bot message. The content we're going to be pulling from our Postgres update Postgres node here, our edit field node, the one where we landmark the bot's message to us. And so we do a dot text, dot replace, strip out all those extra marks. And then we have who it's responding to. So using our user ID, the previous conversation chain, that way our conversation can continue across different tool usages for different bots that you might have. And then the time added. All right, and so that's kind of the standard closeout to make sure that the bot responds to us. It'll give us this response here and log everything in its memory. Okay, once everything is uploaded, assuming that there's no additional files attached that are PDFs or Excel sheets or text files, or you don't include any extra messages that have extra Google Docs in them of any variety, the message will process all the way down to this AI agent here. And this AI agent is a tools agent that is designed to take our current request and any previous conversations that we've had with it. And it's designed to pull information from our RAG, our Retrieval-Augmented Generation database, and it's going to answer our question. So we give it instructions on how to do that. It needs to break down our question, our query, into its key attributes, key relationships. It may need to understand that the previous conversation that we've had with it may include the actual thing that we're asking it to do. And our current message is just giving it context to make sure it does the retrieval correctly. It needs to retrieve those most relevant documents from the database store by converting the query into a semantic vector representation, executing a similarity search to find the top ranked documents and filtering the results based on metadata, process it, extract it, generate a response to us, ensure that it's all relevant and factually consistent with the retrieved documents. It needs to summarize it if it needs to. And then if no relevant documents are found, it needs to let us know that if we didn't find anything. It's not good. We do not want it hallucinating. Instead, just let me know you didn't find anything, brah. All right, we give it a chain of thought to do all of that. So I'm not going to necessarily go through that. It's pretty much understand the query, get the documents, process the information, generate a response, and then how to handle some edge cases. We give it some what not to do's. Do not hallucinate information or fabricate answers. Do not provide responses outside the retrieved documents unless explicitly stated. Do not assume facts not present in the retrieved results. Don't return unprocessed raw data. Always summarize or contextualize. And do not return incomplete or unstructured responses. And then we give it some examples of inputs and then an output. And what we do is we have a tool attached to this. It's a vector store tool. And the model that we have here is a 4.1 mini. And so we come over to our vector store tool. The description of it retrieves data relevant to the user's request. It's going to pull 10 items, and we're pulling it from our Supabase vector store to connect your Supabase account. Our operation mode is retrieve documents as a vector store for a chain or tool. We're telling it what table to pull from, so the dynamic knowledge base. You can again name it whatever your table is. Make sure your match query is correct. Match the correct table, otherwise it will not pull that data. Then we have an embeddings model. The embeddings is the text embeddings 3 small. And then it'll pull the information and then respond to you based on what you asked. And we saw 2 examples. I just asked, what effect is AI having? And it gave me all this information. And when I asked a more specific question, it gave me the very specific information. And so it is a beautiful RAG. It's honestly one of the better RAGs that I've seen on YouTube so far that anybody's given away. It is dynamic. So if you do not want this RAG to delete information, all you really have to do is delete this one node here, and then it's going to be a long-term storage RAG. It will no longer delete any information from the table. But again, I built it, not dynamics. What is this? I've had this the whole video right there. Dynamic knowledge base. But if you want it to have long-term forever storage, delete that node. If you want it to be able to delete information because you want it to have the most relevant information, then you can do that. You can also change the date, like I said, 1 day, 2 days, 3 days, however long you think is acceptable for you to have a dynamic storage model. If you found this video helpful, please make sure to subscribe to the channel, like and share the video. It really does help get this information out there to those who need it. If you would like today's workflow, please feel free to join my free school community. The link is in the description below. The JSON file will be there for you to download, as well as a ton of other helpful N8N tutorials, a ton of other great N8N workflows to be able to build out your AI agents, everything from social media posting bots, executive assistants, lead scrapers, and everything in between. It's all there available for free in the free school community. As always, I'm Bradford Carlton. Let's automate your success together.